Hello and welcome to another of Mrs. C's maths lessons. Right, so hopefully you have a lovely floor plan of your two-bedroom bungalow in your book, drawn neatly with pencil and marked, okay? So the scale was for every 1 centimetre. In real life, the diggers would be digging out 100 centimetres, okay? 1 centimetre equals a metre, if you like, okay? So in your book, this will have measured 3.4 centimetres. You should have drawn it, and then 3.2, and then, oh, it doesn't say there. You could have had a guess at how long that one should have been. Okay, so that 3.4 centimetres in your book, in real life, is 3.4 metres. 3.4 metres. Okay, so all you should have done is mark these with metres, okay? Okay, metres there, and metres there. And hopefully it's all nice and neat. It's such a shame I can't see it, but I'm sure you did it really well. Let's go on to today's lesson. Right, before we go on to lesson 17, today's lesson, I just want to see if any of you spotted my deliberate mistake yesterday. We were talking about scale in lesson 16, and I wrote on the board a scale which was 1 to 100. 1 centimetre equaled 100 centimetres on a scale drawing that we were looking at, okay? So we had 10.5 centimetres, and we were going to see what that would be in real life, not on the drawing, okay? So we times that 10.5 centimetres by 100 to make 1,050 centimetres in real life. Then I was rushing away because I wanted to go on to something else, and I wrote 10.5 centimetres, that equals 1,050 centimetres, which is 1.5 metres. And then I gave myself a big tick like that and said, let's move on. How many of you went, that's not right? Because of course 1,050 centimetres doesn't equal 1.05 metres. How could it? Because there are 100 centimetres in a metre. Okay, so that was wrongety wrong, Mrs. Cumberland. And what it should have been was 10.5 centimetres equals 10.5 metres. Of course, on a scale of 1 to 100. Anyway, wow, I just threw my glasses off. I'll just get them. That was good, wasn't it? Okay, we're back now to lesson 17. So write in your books, lesson 17. We are going to go on to algebra today. Okay, algebra 1. So when we talk about algebra, we've been doing it all year actually, and algebra is basically just missing number problems, okay? And in algebra we talk a lot about equations. We talk about a lot about equations in all of maths, okay? So let's look at what one is. An equation is a number sentence with two equal parts, okay? So this is an equation. Told you it came up a lot in maths. 2 plus 2 equals 4. And this sign here is the symbol, the math symbol we use, which represents equals. So this side equals that side. So 2 add 2 is the same as 4. They are equal, they are balanced. You have to balance each side of the equation. So to solve, well, I've just said that, to solve an equation, you need to balance its two parts. Make them equal. So let's have a look at this, right? Blank plus 7 equals 19. So you need to make this side, this symbol here, be the middle, and this side needs to be equal to that side, okay? So what plus 7 equals 19? If you remember, you need to do the opposite. So you've started off with a number, you've added 7 to it to get 19. So to get back to what should be in this box, you take that 7 away from 19, okay? So what goes into the box? 12, add 7 equals 19. So now that is equal. We have balanced out that equation. And this is algebra. Because when you get a little bit further up and you start key stage 3, you don't have blank boxes around the place. You take this box out and you write instead X. Not necessarily X, you could write A, you could write B, you could write any letters of the alphabet. It just means that that box is replaced by that X. X plus 7 equals 19. So therefore, what is X? What is X? You do the opposite operation. So you take that 7 away from 19. So X equals 12. Bingo. I'll come back with a couple more. We'll go through them. Then I'll set some work for tomorrow. Right, okay. Here come a couple of algebraic equations. Well, they don't look very much like algebra at the minute, but they will in a moment. Okay. So we've got box divided by 6 equals 3. So, we're going to replace that box with an X. Why do you write the X like a curly that way than that way? Because if you did that, that symbol is times in maths. So X in an algebraic sense is always made different to that times symbol by doing a backwards C and then a forward C. Okay, that explains that. So X divided by 6. Now, we write that like you would a fraction, because of course a fraction is like a division of a whole, isn't it? So this X divided by 6, in an equation you would see it like that. That means divided by, X divided by 6. That's how you would write divided by in algebra. Don't be scared, it's easy. Equals 3. Equals. So this side of the equation has got to be equal to that side of the equation when we're trying to solve it, okay? So something divided by 6 equals 3. So to make it equal, to find out what X is, you're going to have to do the opposite on this side. So you divided by X by 6. So to find out what X equals, you have to times that by 6. Opposite operation, yeah? So X divided by 6 equals 3. So 6 times 3 will equal X. 6 times 3 is easy. Right, here, 4 times box minus 5 equals 23. So we get rid of that times box. Well, actually, to begin with, we'll just get rid of the box and we'll put X in there. You can see really clearly now why you need that X to be drawn like that and not like that, because it would look like extra, extra large, wouldn't it? You wouldn't know what you were doing. So 4 times X minus 5 equals 23. In a maths equation, you will always see 4 times X written like this. 4X. That means 4 lots of X, okay? So you never see it written like that. It would always be 4X. So that's 4 of something minus 5 equals, that's the important bit, 23. So we've got to solve what that X is. Okay, that missing number problem. That's all it is, okay? So let's try to get that X on its own. That's what I always say. Then you're working out what it's worth, okay? So 4 lots of X minus 5 equal 23. So therefore, what do 4 lots of X equal? Let's get rid of this minus 5. So we're just getting down to find out what that X is equal to, balancing that equation. So if you've minused 5 from it to get 23, you've got to add that 5 back on to start to solve this. Opposite operation all the time. So 4 lots of X minus 5 equal 23. So 4 lots of X equal 23 plus 5, okay? So 23 plus 5 would be 28. Agreed? Okay, so 4 lots of X equals 28. Let's balance the equation, see what that X equals. So X equals, so you've timesed 4 by X there. So on the other side, you divide it. So X equals, how many 4s in 28? 7. 7 fours are 28, of course. Boom! We can do this. Right, let's do these two here together. Then I'm going to set you some work. I'll just take those off. And I'd written those down so I didn't forget them. X divided by 2 minus 5 equals 17. Okay, so x over 2 means x divided by 2. Equal sign is here. We need to find out what that little x there is worth, okay? So we do opposite operation to get that x on its own, really. So x divided by 2 equals 5 plus 17. So 5 plus 17 is 22. So x divided by 2 equals 22. So what does x equal? Opposite operation. So that is half, isn't it? That is half of x. So you're dividing x by 2, so you do the opposite to this side. So x equals, times it. 2 times 22 is 44. Okay? You're getting that x on its own to balance the equation, okay? And you get it on its own by doing the opposite operation. And then you're working out what it means. It equals is equal. It's almost like that is the middle of your seesaw, if you like. Right, let's do this last one. Done that one. 3x plus 2 equals 20. So 3 times x, 3 lots of x, plus 2 equals 20. Okay, so this side of the equation equals that side, as if that were the middle of your seesaw. Okay, we need to get x on its own to find out what it is equal to. So we need to do the opposite operation with these bits of maths to work out what the x is, okay? So 3x plus 3x plus 2 equals 20. So 3x with 20 minus 2, okay, is going to be equal as well, isn't it? Okay, so you're doing the opposite operation. So therefore 3x, 3 lots of x equals 18. 3x is 3 lots of x. So 3 lots of x equal 18. Balance that equation. X equals 18 divided by 3. How many lots of 3 in 18? How can you make both sides equal? X equals 6. Oh, I think you're going to absolutely smash the work I'm going to set you today. Okay, let me put it on the board and leave it to you, and we will look at the answers next lesson. Right, here we are with today's algebraic equations to solve. There are 10 of them. They start off quite easy. Okay, so remember that's 45 lots of x, and this is x divided by 3. Okay, you need to balance each side of this equal sign to find out what that x is worth. Okay, what does the x equal? Okay, so with these ones from 7 onwards, you need to get the 3x on its own. So you need to solve this bit first, okay? So even here, when it's x divided by 2, you need to get that on its own, solve this bit first, and then work out what the x is equal to. Remember, always do opposite operation when you're taking this working out over the other side. You have to do the opposite thing to this number to keep the equation balanced, okay, to keep those numbers equal. Good luck. You can do it. I'll be back with the answers next time. Remember to like, subscribe and turn on post notifications.